You lose most of your body heat out of your head. That's why your mom always told you to wear a hat when you went outside in the winter. But why exactly would you lose more heat through your head than some other body part? Does your brain really generate that much energy and need to emit excess heat as a result? Hi, I'm Justin Dodd. Welcome to Misconceptions. Considering how familiar we all are with the human body, since we all, have one, there are a surprising number of enduring misconceptions about it, from our 5 senses to the oft-quoted normal human body temperature of 98.6 degrees Fahrenheit. Let's dive in. You lose most of your body heat through your head. As you probably guessed by the preceding graphic, all things being equal, you do not actually lose a disproportionate amount of body heat through your head. Rachel C. Vreeman and Aaron E. Carroll, both pediatricians, looked into the origins of this misconception in a humorous 2008 BMJ paper. They found that the heat lost through your head concept had been widely adopted by 1970. A US Army survival manual issued that year recommended wearing hats in cold weather because 40 to 45% of body heat is lost through a person's noggin. That figure apparently came from Army research conducted during the Cold War, a period of geopolitical tension set off, I want to say by a disagreement about the merits of wearing a beanie? I don't really remember. Maybe check out our episode on misconceptions about the Cold War to fact check that. According to hypothermia expert Daniel I. Sessler, during that now decades-old experiment, scientists dressed volunteers in cold weather survival suits and subjected them to freezing temperatures, after which the researchers evaluated the performance of the suits. It appeared that a significant percentage of body heat was lost through the head. But as Vreeland and Carroll noted in 2008, the suits did not include hats. Because the head was the only part of the subject's bodies that was exposed to the cold, they lost the most heat through their heads, they reported. If the same experiment had been done with the unfortunate volunteers wearing nothing but bathing suits, the head would not have contributed to more than 10% of the body's heat loss. A 2006 study submerged 8 participants' heads in cold water and came up with essentially the same conclusion. After evaluating the effects of the dunking, researchers found that the head does not contribute relatively more than the rest of the body to surface heat loss. But that doesn't mean winter hats are worthless. Though surface body heat loss may be pretty consistent for any uncovered body part, there is reason to believe that colder heads lead to disproportionately colder core body temperatures. This might be because you have more close to the surface blood vessels in your head, or it might be because you don't tend to shiver when only your head is cold, meaning you lose out on shivering's warming effect. Did you know shivering warmed you up? The body's amazing and weird. A person's normal body temperature is 98.6 degrees Fahrenheit. If we've learned anything from having our body temperature examined by total strangers at restaurants during the last few years, it's that 98.6 degrees Fahrenheit is normal. Anything hotter than that means you're not only going to miss dinner, but also have an upcoming date with an uncomfortably long cotton swab. Actually, we've known for at least the past 25 years that the 98.6 degrees Fahrenheit standard is a myth. So where did that curiously precise number come from? Back in the mid-19th century, German physician Karl Wunderlich sought to understand how body temperature related to disease. At a hospital in Leipzig, where he was the medical director, Wunderlich took patients' temperatures with a foot-long thermometer stuck into their armpits, over 1 million measurements in all. From there, he determined what he deemed the average normal temperature of the healthy human body. In his 1868 treatise on the temperature in diseases, he wrote that a fundamental principle of medical thermometry was that healthy human body temp varied between 37 degrees and 37.5 degrees Celsius, noting that the temperature of an armpit was closer to 37 degrees and that of the rectum or vagina was a few tenths of a degree higher. He also suggested 38 degrees Celsius as the threshold of fever, indicating the presence of disease. The 98.6 figure that Americans are familiar with, which seems so oddly specific, is just the result of converting to Fahrenheit. It may give a misleading perception of precision for what was originally a range of fairly round numbers. But that may not be the only problem with citing Wunderlich as the final word on body temperature. In the 1990s, a professor of medicine at the University of Maryland thought Wunderlich's number sounded a little too precise. Philip Makowiak borrowed one of Wunderlich's thermometers from the Mutter Museum in Philadelphia, and his suspicions grew. He saw that the temperature could be read only after the instrument had been in place for 20 minutes. He also believed that the armpit was a much less reliable locale for accurate measurements compared to the mouth or rectum. And when he examined the accuracy of the instrument's readings, Makowiak found them to be several degrees off. In his 1994 paper revisiting Wunderlich's findings, Makowiak cited a 1950 study that noted differences in quote-unquote normal temperatures in the morning and at night, neither one of which was as high as 98.6. In Makowiak's own analysis of 700 temperature readings from 148 adults at the University of Maryland, only 8% of the readings were 98.6. In this group, he wrote, 98.6 degrees Fahrenheit was not the overall mean temperature, the mean temperature of any particular time of day, the median temperature, or the single most frequently recorded temperature. Any similarly rigid standard for body temperature in Celsius without accounting for healthy variation would be similarly misleading. And recent studies have pointed to another potentially confounding variable. Human beings may be literally cooling over time. A 2020 paper looked at body temperature databases from the Civil War era up until 2017 and found a drop of 0.03 degrees Celsius per decade. According to New Scientist, it's possible that modern people have fewer infections thanks to vaccines and antibiotics, so our immune systems are less active and our body tissues less inflamed. I should note that we're still in the early stages of this research, and not all experts are convinced the trend is real. I, for one, refuse to believe my great-great-grandpa was hotter than me. All humans have 206 bones in their body. You'd think that something as fundamental as the number of bones in a human skeleton would be pretty easy to figure out. You would be wrong. Scientists have been counting our clavicles and tallying our tibias for thousands of years, but they haven't always been able to agree on what that total number is. According to a communication in the journal Clinical Anatomy, medieval Europeans thought there were 248 bones. In 1543, the Padua surgeon Andreas Vesalius revised that number to a little over 300. In 1732, the best estimates pegged it at 245. And then in 1858, we finally got to the modern 206 thanks to Henry Gray of Gray's Anatomy. The reference book, not the TV show, which I believe only debuted in the late 1890s. You could write all that off as scientific progress. We had an erroneous idea and supplanted it with better information. People have 206 bones. But as the dreamy doctors of Seattle Grace Hospital could no doubt tell us, not every human has 206 bones, far from it in fact. Babies are born with more than 300 soft bones, mostly made of cartilage, connected by a tissue of cells called osteoblasts. These cells emit a sticky goo of collagen and sugar molecules that traps inorganic minerals. When enough of the minerals are caught in the gluey tissue, they harden and form compact bone, the type that provides our skeleton structure. As they grow, an infant's cartilage-based bones will dissolve and be replaced by clumps of osteoblasts that foster bone growth. Many cartilaginous bones will fuse through the process of mineralization, reducing the total number of bones in the process. In the limbs, bone formation continues through childhood and adolescence, and finally ends when the bones have reached their adult length. You may know that a newborn's skull consists of several sections that eventually fuse together. If you look at an adult human skull, you can see the lines, called sutures, where these plates meet. So that's how we go from 300 or so rubbery baby bones to the usual 206 mature bones. But not even every adult has that exact number. For example, people can be born with an extra set of ribs accompanying the normal 12. These supernumerary ribs are usually found along the lumbar vertebrae, those in the lower back, and typically go unnoticed until a person is x-rayed or autopsied. There's no scientific consensus on how common these extra ribs are, with estimates ranging from less than 1% to as much as 16% of the population having them. Another phenomenon in which humans sport extra bones is polydactyly, or extra digits. You might have heard of Ernest Hemingway's famous polydactyl cats, which have 6 toes instead of 5 on their front paws. Polydactyl humans can have an extra finger or toe on one or both extremities, usually due to mutations on one of several genes. The extra digits are most often located next to the outer digit, the pinky finger or little toe, though supernumerary thumbs and other fingers have been documented. These digits can sport extra bones, though not always a full set. Polydactyly is surprisingly common. It affects about 1 in every 700 to 1,000 babies. Devendra Suthar of India holds the Guinness World Record for the most supernumerary digits with 14 fingers and 14 toes. We have 5 senses. For much of human history, humans were believed to have 5 senses: sight, smell, taste, hearing, and touch. This idea can be tied to Aristotle. In his treatise on the nature of the soul, titled De Anima, and written around 350 BCE, he argued that humans have 5 special senses divided into 2 categories. He considered touch and taste to be senses that were perceived through direct contact. Sight, smell, and hearing were accomplished through a medium in Aristotle's understanding, either air or water, which corresponded to 2 of the 4 elements that ancient Greeks believed made up the universe. In addition, Aristotle noted that each sense had its own designated organ, such as the nose for smell, which he felt further supported his theory of exactly 5 senses. Today, scientists believe humans have many more senses than the basic 5. Proprioception, for example, is the sense of knowing where our body parts are and what they're doing. This sense makes it possible to run without staring at our feet or to pick up an object without looking at it. Equilibrioception is basically our sense of balance, which allows us to stand upright and bend over without falling, not to mention the ability to walk slack lines in public parks while your friends look on bored. Chronoception is our sense of time passing. And like the number of bones in the human body, the different senses can sometimes join or overlap. Synesthesia is a well-known phenomenon in which people say they can see sounds, hear shapes, or even feel mathematical equations. Research suggests that synesthesia runs in families, pointing to a genetic component, but its cause is still not well understood. As much as 4% of the population has gene variants that might be connected to synesthesia, including such famous synesthetes as novelist Vladimir Nabokov and musician Duke Ellington, along with, perhaps, artist Vincent van Gogh. And, of course, Bruce Willis might have something to say about another sense, but our fact checker has not gone back to us about the validity of that one yet. My chronoception is telling me that we're out of time. Is there a question you have about the human body? Drop it in the comments below. Thanks for watching Misconceptions, and I'll see you next time.